Hi, thank you so much for inviting me. My name is Kevin. I'm a graduate student in the Yard Lab. And today I would like to share with you guys some of my experiences so far with using Neuropixels in BATS wireless in wireless recordings. So in the past, in our lab, we primarily relied on using tetrodes for our wireless electrophysiology. And one of the main limitations with tetrodes is that it is quite difficult to scale to large population level recordings. So we decided to turn to NeuroPixels because it has been shown to be quite promising for large scale recordings in freely moving animals. So going into this project, we kind of anticipated two potential problems or challenges. So the first challenge is, can the bats actually carry an entire wireless implant and still fly with it, because these implants are much larger than what we have used in the past. And the second challenge was because flying is quite a physically intensive behavior, we were concerned if we could actually record and isolate stable single units during flight. So to do this, we relied on a wireless recording system developed by Spike Gadgets. And in this system, it consists of a main control unit, which is connected to a computer, and it communicates wirelessly with a head stage. So this head stage sits on the animal and can record from up to 3 probes, NeuroPixel 1 probes at a time, for a combined total of 400 channels. And all the neural data is logged locally onto an SD card in the head stage, which we retrieve after each recording. So zooming in a bit on the head stage, it consists of a protective cone, which is cemented to the skull of the animal and essentially holds the whole implant together. A probe connector, which acts as an interface between the probes and the head stage itself. And the connector also serves as a protective housing cap that essentially encloses the whole implant and encases the probes inside. So this connector piece is meant to stay on the animal throughout the duration of a chronic implant. So when we want to record, we simply attach a head stage, a battery, as well as SD card. Here in the schematic, I have the battery shown on top, but we would actually recommend putting it on the back behind or in front of the animal to improve the user experience for the bats. So this implant is quite large. However, we found that the bats can readily carry this weight and fly with it with seemingly minimal impact on their ability to fly, which is really, really nice. I would like to note that in this design, the probes are not directly attached to the implant itself. So the implant itself is just an empty cavity, and the probes are essentially independently inserted and attached directly to the animal. So this method allows for more flexibility in targeting multiple different brain regions. It also makes it easy to incorporate things like retrievable holders to allow the probes to be reused after each chronic implant. In our lab, we use a custom bare bones design, which just consists of an internal and external shuttle. And then the probe essentially attaches to the internal shuttle via the same dovetail design as that comes with the probe itself. And however, any retrievable holder design can be used here as long as it can actually fit inside the cavity of the implant itself. And the cone here, we usually design ourselves depending on the trajectories we choose. So it can be enlarged or reduced in size as needed. For our procedure to implant these probes, we adopted a two-step process where we separate the probe insertion from the surgical step itself. This is based on some previous work done in the Nelken lab. And the main reason we do this is so that we can allow the animal to fully recover and adapt to the extra weight on their heads before we start we insert the probe. So in the base surgery, we try to do as many of the invasive steps as we can. That includes exposing the skull, performing the craniotomy, as well as inserting the ground screw. At the end of the base surgery, we cement a training cone onto to close everything up. And we allow the bat to fully recover for up to a week. And then we start to retrain the bats to fly by progressively overloading weights onto this training cone until the training cone weight matches what the implant will eventually be. Um, Once the bat is fully trained, fully recovered, we remove the training cone, insert the probes, and cement a fresh cone. And typically we start to our recording experiments within a day after the probe insertion step. So this two-step process essentially allows us to maximize that short window where we have really, really good signal quality after we insert the probes. And I'll show a little bit more later on about how our neural yields change over time. So we verify functionally that we can record stable single units during flights. So this is an example of a place cell from the hippocampus in a flying bat. And as you can see from this raster plot that's showing the spikes of this neuron aligned to takeoff flights, it exhibits stable spatial tuning across many flights over the course of a 2-hour or so recording. One of the things that we found quite surprising was that we actually see not too much drift in our recordings. We're very much prepared to see for the worst, as we're expecting some crazy movements when the bat's like flying around and stuff. But this is a pleasant surprise, and we're definitely not complaining. And we find that in the initial days of after probe insertion, we can typically record several hundred neurons at a time. However, we do see after a couple of days that the neural yield tends to drop quite significantly and eventually plateaus somewhere around 50 neurons or so. So this has been an ongoing challenge, and that unfortunately we have yet to be able to solve. So if anyone has any suggestions, advice, or has any questions in general about neuropixels in bats, feel free to reach out to me afterwards. And with that, I'd like to just thank my advisor, Michael, and the rest of my lab, and particularly Tatsumi, who has helped me a lot throughout the implementation of neuropixels in bats. And thank you everyone for listening.